Okay, students, in this video we are looking at angles of polygons. Alright, so a polygon is any two-dimensional figure with at least 3 segments, and it has to be closed. So the smallest polygon that we could have would be a triangle. A triangle is the smallest polygon, followed by quadrilateral has 4 sides. Quadrilateral could be a square, rectangle, parallelogram, kite, trapezoid, rhombus, anything with 4 sides. If we have anything with 5 sides, we call that a pentagon. 5 sides would be a pentagon, something like this, and so on. 6 sides, it could be a hexagon, 7 sides, heptagon, and so on. So after 10, with the exception of 12, we just add the number of sides and then attach the suffix gon at the end. So if I have a polygon with 11 sides, you would call that 11agon, and so on. So let's look at all the interior angles of a polygon. So if I was to take the interior angles of this triangle here, so angle A plus angle B plus angle C, I will get a sum of 180 degrees. If I take the interior angle of the next polygon, this quadrilateral, if I take angle D plus angle E plus angle F plus angle G, I will get a sum of 360 degrees. And if I take all these angles of this pentagon and add them, I will get a sum of 540 degrees. So there is a pattern. If I have 3 sides, I get a sum of 180. If I have 4 sides, I get a sum of 360. 5 sides or 5 segments, I get a sum of 540. So is there a formula that can give me the interior sum, or the sum of all the interior angles? And the answer is yes, there is. So it's this formula, n minus 2 times 180 degrees. This will always give me the sum of all interior angles. Alright, so this one here, this is going to give you the sum of all interior angles. N stands for the number of sides. Alright, so N stands for the number of sides. So if we have let's say a shape or a polygon with 10 sides. If we have a decagon has 10 sides. Decagon has 10 sides. So I would take 10 and substitute it into n. So 10 minus 2 times 180, and that will give me the sum of all the interior angles. So in this case, it's going to be 10 minus 2 is 8 times 180, and I get a sum of, well, let's see, 1,440 degrees. That would be the sum of all the interior angles. Alright, so you can apply this formula here to any polygon when you're looking for the total, the sum of all the angles in any, all the interior angles in any polygon. Alright. We also have something called a regular polygon. And a regular polygon is basically, this is a polygon, a regular polygon. So a regular polygon is a polygon with congruent angles and all congruent sides or segments. All right, so this pentagon is called a regular polygon because all the sides are congruent as well as all the angles are also congruent. All right, so we know that to find the sum of all the angles in this polygon, I can do n minus 2 times 180. But if I know it's a regular polygon and I'm looking for each interior angle, then I can simply divide all that by the number of angles or by the number of sides. So this is going to give me the measure of each interior angle in a regular polygon. Remember, regular means all the sides and angles are the same. All right? So just keep that in mind. The one we looked up, the other formula up here, this one here is to find the sum of all the interior angles. This formula down here is to find the measure of each interior angle in a regular polygon. All right, so if I give you, or if I give you, let's say, the measure of the interior angle of a regular polygon is 108 degrees. How many sides or what type of polygon is this? All right, so what is this polygon? Or how many sides does it have? How many sides? That's probably better. How many sides? How many sides does it have? How many sides? Okay, so again, we're going to use this formula up here, and we know that the interior angle of this regular polygon is 108. So what we do is, so we use this formula, n minus 2 times 180 divided by n is equal to 108 degrees. All right, so let's move this up just a little bit. Let's move it up a little bit and let's work this out. So remember, to get rid of this denominator or any denominator, basically multiply. We multiply everything by whatever that is on both sides. That's how this goes away. We end up with, on the right side, 108n is equal to, let's distribute 180 times the negative 2 into the n. So you get 180n minus 360. Combine like terms, minus 180n on both sides. We get negative 360 is equal to negative 72. N divide by negative 72 on both sides. And n is equal to 5. So this polygon, this regular polygon that has each interior angle of 108 degrees, has 5 sides, which means it's a, so n is 5. That means it has 5 sides. That means this is called a pentagon. All right, hopefully this makes sense. There's one more thing we have to go over. So there's something called concave polygon and a convex polygon. So a concave polygon is any polygon whose so this one up here, this is called a concave polygon. which means is that if you extend any of these lines and any of those lines go inside the polygon, then we call that a concave polygon. Convex is the opposite. If you extend any of the lines here, any of the segments, notice none of these lines go inside the polygon. So we call this convex. Concave, convex. All right, let's see. One more thing. If we have exterior angles, so if you add all the exterior angles, so the sum of all exterior angles add up to 360 degrees. Always. Okay, so this is another theorem. The sum of all exterior angles add up to 360 degrees. This is regardless of whether it's triangle, quadrilateral, pentagon, you name it. When you add all the exterior angles, you will always find that it's a sum of 360 degrees. All right. Please let me know if you have any questions. Have a great day.